In theory, a turbo is simply a hot air pump that forces more air into the engine. With more air, the engine can generate power more efficiently, improving performance, reducing fuel consumption, and cutting emissions. The turbo is mounted in the exhaust system between the exhaust manifold and the exhaust pipe. As exhaust gas exits the engine, it drives the turbine, which turns the compressor, pulling in air and compressing it. Oil passes through the turbo, providing vital lubrication. In practice, the turbo is a highly efficient, complex piece of engineering built to tolerances of thousandths of a millimeter. It comprises a turbine and compressor connected by a shaft supported on a bearing system. The turbo is driven by the waste energy from the exhaust gas. The exhaust gas enters via the turbine housing, turns the turbine, and leaves through the exhaust outlet. Exhaust gas temperatures can reach 950 degrees C, which means that special high-temperature materials are needed for the turbine wheel and housing. The speed and load of the engine determines how fast the turbine wheel spins. With the engine at idle, the turbine spins at minimal speed. As more gas passes through the turbine housing, the turbine rotates faster. At full speed, the turbine wheel can rotate at up to 360,000 RPM. That's 6,000 revs per second. The compressor wheel is connected to the turbine by a forged steel shaft and is powered by the spinning turbine. Air is drawn into the compressor housing by the compressor wheel and is compressed as the blades spin at high velocity. The shape of the housing converts the high-velocity, low-pressure airstream into a low-velocity, high-pressure airstream at the outlet. Air enters the compressor at ambient temperature, but leaves it at up to 200 degrees C. As air temperature increases, its density decreases, which reduces power. So it's usually passed through a charge air cooler or intercooler, which uses air or water to cool the hot, high-pressure air. The forged shaft linking the turbine and compressor runs in a bearing housing, lubricated by oil from the engine. The oil is fed under pressure into the bearing housing to the journal bearings and thrust system. The oil also acts as a coolant, taking away heat generated by the turbine. The journal bearings float on a film of oil between bearing and shaft and bearing and housing. The clearances for these oil films are critical. At both ends of the bearing housing are unique oil seals. Totally unlike normal engine oil seals, they're specially designed to cope with the turbo's extreme temperatures and pressures and help ensure that oil does not leak into either compressor or turbine housings.